All right, now for pulleys, all right, we're going to show you a little demonstration using Kalani here, my special helper, of how a pulley works and how it can help you. So Kalani here has, let's see if I can show you here. She has a bucket, okay, that's filled with some rocks to make some weight, okay. Kalani's going to lift that bucket. All right, what do you think, Kalani? Pretty heavy?
No, not too heavy.
Not too heavy for you? Okay. Here we're going to show you an example of one way that we can use a pulley with this bucket. All right, so Kalani's holding the string here. We have a single pulley system. All right, you can see the wheel with the ridges on the end, so that the string runs right in between them. And Kalani's going to go ahead and pull that string. All right, and now remember, a pulley, one thing a pulley allows you to do is to change the direction in which you are applying force. So Kalani's able to pull down to lift this bucket up. Awesome, nice job. All right, guys, so that video that you saw with my daughter involved a single pulley system, okay? So a single pulley system is just one pulley that you're gonna go with the string up and around, or the rope up and around, and you're gonna pull it. Now, using a one pulley system does not give you that much of a mechanical advantage. Again, it's gonna be equal to one, okay? So the only thing it really does for you is it allows you to change the direction, which Kalani was able to pull down to lift the bucket up. So that's all it's really going to do for you. Again, that does give you a little bit of an advantage, but mathematically, you're putting the same amount of effort or the same amount of force into it that you're getting out of it. So it's not actually going to give you that much of a mechanical advantage. What I want to show you here is that there are more options than just a single pulley system. So the first one that I have here, I grabbed a couple from school. The first one here is called a double tandem pulley. All right, it's called tandem because they're on top of each other like this. All right, and you can use these in different configurations with the rope that will actually, decrease or increase the amount of force that you're getting out of the pulleys. Okay, so generically speaking, every pulley that you add is going to decrease it by 50%. All right, like the amount of effort that you need to put into it. So if something normally takes 4 newtons of force to lift, adding 2 pulleys is only going to, require about 2 newtons of force to lift, okay? It has some stuff to do with the radius of the pulley and stuff, but not really stuff that we're getting into with this. So double tandem pulley. They also make triple tandem pulleys, okay? And again, you can see how the radius of the pulley is significant and will play a role. But again, that's some math that we're not getting into. Some other ones I'll get into. So tandem this is a triple tandem pulley. A triple pulley, all right, looks like this, where you have 3 pulleys side by side. And again, you would kind of go around and around and around, okay, each one. They're going to work the same way, all right? So, 3 pulleys here, it's going to decrease it by 50%, 50%, okay, so about 75%, generally speaking, all right? And I'm going to show you a couple string ups here, okay? So, triple pulley, triple tandem pulley. There, you see the difference there. And then we have a quadruple pulley, all right, which you guessed it, has 4 pulleys side by side. So there are a lot of different configurations. You guys can certainly look them up. I'm going to show you one here, just so you can get an idea of, we're going to use 2 single pulleys, all right, to create kind of a double pulley system. All right, guys, so I'm stringing up my pulleys here. So in my first one here, I have a single pulley up here, and we're going to use some yarn here. All right, so that's nice and red, so you can kind of see, all right, how to string this up, all right, if you ever want to do it. So to string a single pulley system, you just go up and around, all right, and you have it right there. So you can have, a weight attached to one end and use it. Again, this isn't going to really give you too much of a mechanical advantage. It's just going to allow you to pull down, change that direction of the effort force, okay, or the effort force or the force that you put in. If we add in another single pulley, all right, and these pulleys are not the greatest, so have a lot of trouble keeping the string on here. If you get ones from like actual really good pulleys, they have little spaces on top where the string or the rope can't pop out. One of the most frustrating things with these guys is that this rope can pop off the pulley, and then depending how complicated you make it, can be very, very frustrating. So if you look here, I went up and around this pulley, all right, this top pulley, up and around, and then this one I went down underneath the pulley, okay, and it just slipped off there. So I'm going to fix that in a second. All right. Oh, frustrating. All right, so let me go ahead and get these set up here. So around the top on this one. All right. And then this one I'm going to go down underneath. Okay. And for right now I'm just going to let it hang there. I'll fix it in a second. Just want to get it underneath here. Okay. And then we're actually going to tie it back to the bottom of this top one here. Okay. So up and around the top one, down underneath this one. Okay. And then tying it back up to the top one there. Okay. So you can see that there. The weight that you want to attach to it goes on the bottom of this pulley here. All right, and this is a double pulley system right here. So you can see that I can pull up on this, and it's actually taking 50% of the effort, you know, that I have to put in to lift this weight. Now, again, kind of that trade-off that we talked a little bit about with the levers. You do actually have to pull twice as long to get the weight to a certain height as opposed to with a single pulley system. So again, back to that, you know, how long do you want to do the effort or the force that you're putting into it, you know, to achieve the result versus how easy do you want it to be. So this is a double pulley system, and again, you guys can look up, you know, a lot more, you know, triple tandem pulley systems. They can get pretty complicated, and they are actually kind of fun to string up. So if you guys have availability of that, feel free. All right, guys, so next simple machine that I want to talk about here is a wedge. All right, so a good example of a wedge, you know, wedges are designed to split things, make it easier to split into things. So if you remember what I said about a wedge, it's actually two inclined planes put together, all right, or it can be multiple in some cases, but for the most part, two inclined planes. So on an axe here, a little hatchet, you actually have an inclined plane that goes in this way and an inclined plane that goes in this way, all right, to give you that nice sharp point. All right, when you need to sharpen things like this, you're really trying to increase that those inclined planes. So you can use a wedge to split things. All right, so you can get down in there. You know, make life easier with that. But a wedge is pretty straightforward. That's just used to split things. So things like tacks or splitting into a board or something like that, or axes or knives or scissors, all right, all have wedges on them. Okay, so one of the wedges that I just mentioned was scissors. All right, and I kind of want to show you this and see if I can show it to you up close here. And if you have a pair of scissors, you can kind of see this too. But with the inclined plane here and how these form a wedge to cut something, all right, on this side is one inclined plane. On this one is another inclined plane, all right? And when they come together, it's two inclined planes, all right, that are touching, all right, or come together to form a cut and perform the action of a scissor. All right, so for inclined planes here, all right, what we want to focus on is an inclined plane is not only, you know, just any slope, okay? So any slope has an incline or a decline, but what we're specifically talking about with inclined planes is something, you know, a ramp that helps us to get from a low spot to a high spot. So for example here, at my shed, I have a ramp, all right? That's gonna help me get stuff into my shed, you know, from, instead of just picking it up and putting it in, all right? This is gonna make it easier. So with this, we use some math equations to figure out what our mechanical advantage is. All right, and the things that are important with that is the first one is the height of it. All right, so how high are you trying to get from the ground to the top? All right, the next one is the length. All right, so the length of the ramp. Now with the length of the ramp, what's important there is what is the slope gonna be? Okay, so you know, kind of a rise over run. So a much shorter ramp is going to give you a much steeper slope. Okay, so probably not going to give you a huge mechanical advantage, not make your life very easy, because that's basically like picking it up and putting it in there. The longer you make the ramp, the higher mechanical advantage you're going to have, okay, because it's going to be much, much easier. But it goes back to our trade-off, you know, kind of like with the levers and the pulleys. How long do you want to push something up a ramp to make your life easier versus, you know, how much do you just want to get it done? Okay, so there's a little bit of a trade-off there, but that's important there, right? So a ramp is probably one of your most, you know, clear-cut examples of an inclined plane. Another good example of an inclined plane would be like a ladder, all right? So a ladder is going to help you get from a place, low place, to a high place. It's the same thing as a ramp. It's just a little bit modified, all right? Just like stairs are modified inclined planes. All right, with this next example is a wheelbarrow. Now, a wheelbarrow is a great example of a simple machine because it helps us move things much easier than if I would just pick them up and carry them. So there's a couple different simple machines going on here. The first one that I want to highlight is our next one, and that is a wheel and axle. All right, so you guys all know what wheels are, right? And a wheel needs to spin on an axle. So a wheelbarrow is definitely a good example of that. The other example here, okay, going on is a lever. So think about it. I got tough bars. All right, so if I pick, this is my tough bar here, and it's going to pivot on a certain spot. All right, now this wheelbarrow actually is extended past the wheel here, so our wheel is actually acting as the fulcrum of this wheelbarrow. So it's where these tough bars are pivoting. Okay, big time example of a wheel and axle is on a car. All right, these sweet rims. All right, take a pretty cool picture like this. These are my 32-inch rims. But yeah, cars are huge, like 3,000, 4,000 pounds. These guys move them, all right, for pretty easily. Sticking with this idea of cars, all right, your wheel is a wheel and axle system, okay? So this is the wheel, my axle is back here where it's gonna spin on, and this basically helps me move those wheels, all right? Just move a 3,000 pound car pretty easily. Last example of wheel and axle would be this sweet bicycle, pretty old school. Got the green light up on the spokes there. All right, guys, so hopefully you got to see a bunch of examples of some different simple machines. All right, there are tons out there. You know, I'm looking around right now. I see a broom that is a lever. I see a golf putter, which is a lever. I saw a shovel is a lever. A pitchfork is a lever. All right, there are tons and tons of simple machines around your house. Your assignment for Wednesday is to complete the simple machine scavenger hunt. So go around your house, use some of my examples, use examples from the notes last week, and find me your simple machine. So you got to find 2 of each. If you can find a pulley, that's probably the toughest one, the one that a lot of people don't have around their house. Great. If not, don't worry about it. But you should find me 2 levers, 2 wedges, 2 wheel and axles, 2 screws, and I always blank on the last one, 2 inclined planes. All right, so maybe you should find those, tell me what it is, where is it in your house, and take a picture and drop that picture into that document on GoodNotes, okay? That's available for you on Moodle, the scavenger hunt. Go ahead and complete that and email that to me and you'll be good to go. All right, guys, I hope you have a great week. Don't forget your Rube Goldberg projects are due Friday. We don't have class next Monday, so I will be seeing you for a Zoom on Wednesday of next week. All right, so I hope you guys have a good time, and we'll see. I'll look for those emails of the scavenger hunts to roll in. See you guys.